Hello everyone. Now let's proceed with our topic of transportation problems and quantitative techniques. Actually, previously we just explained how to just like this. We just explained how to formulate the problem, and right now we are just going to take a look at the steps involved in solving a transportation problem. So these are the general steps, and then we'll take a look at one after another. First of all, formulate the problem, and I will have seen this already. And then there's a second step that involves obtaining initial feasible solution. Actually, we'll see there will be three methods that we'll use here. And then number three is called checking for. Anyway, before going to number three, you have to understand one thing. After obtaining initial feasible solution, most of the methods, of course, most of the two of them will not reach the optimal solution. Now, to reach the optimal solution, you would have to test for optimality and use the method of optimality that is called stepping stone method to reach at the final result that is optimal. That means if it's cost, minimization of cost; if it's profit, maximization of profit. But we cannot go to optimality while there is something called degeneracy. So we first check for degeneracy, and if it is there, you eliminate it. If there is no degeneracy, if n, which is number of allocations, equals number of sources plus number of rows minus 1, we'll see each of these. So that's why we check for degeneracy. And then if it is there, you resolve degeneracy. After resolving degeneracy, you can now test optimality. And while test optimality, degeneracy may arise again. So you have to check for optimality. You have to check for degeneracy and resolve it whenever you obtain the solution. So that's what we have to do. And finally, you just compute the total transportation cost and you reach the result. So it's just like that. All right, so we'll just follow the following steps to reach the optimal solution. But actually, most methods, most of the time, you could be asked to just obtain initial feasible solution. So here we proceed. Formulation of the problem. What do we mean by step one? That is formulating the problem. By formulating the problem, we simply refer to the following. Set up the problem in a matrix form. You set the problem in a matrix form, which is like this one. You specify your sources, source 1, source 2, and source 3. And then you specify what they can supply units A1, A2, and A3. And then you specify the destinations, which is D1, D2, and D3 alongside their demand, the demand of destination B1, B2, and B3. You just put it in the matrix format. And then after that, actually you proceed now. You balance, we say, balance the problem if it is unbalanced. This is a very, very important step. How do I know that the problem is balanced or unbalanced? We say the problem is unbalanced if total supply is not equal to total demand. So you count total supply. If you find it different to total demand, actually you have to force. Let's say demand is 800 units and supply is 850 units. Then you would have to add the supply by 50 units so as to make it equal to the demand. So we say, if unbalanced, add a dummy source or dummy destination. It depends on which is not sufficient. So I just add a dummy source or dummy column, destination I mean, and assign 0 cost to new cells created. You have created new cells, and then you just have to add put the 0 cost there. Let's see an example. So through this example, you are just going to learn a lot. So just be patient until we finish all this. So you can find it here. We say the following data regarding demand and supply relates to ABC Limited. Transportation costs are on a per unit basis, just like how we are provided with the information down here. So we have 3 sources, source 1, source 2, and source 3. With the following supply and have destination with the following demand. So required, what are we required to do? We are told convert the above unbalanced transportation problem into a balanced transportation problem. How do you balance this? It's just simple. You just count total supply and total demand. Total supply equals to 150 for source 1, 400 for source 2, and 350 for source 3, which gives you a total of 900 units. And then you go to destination, 300 destination 1, 200 destination 2, and 250 destination 3. So you just add them and you find them they have different values. So total supply would give you 900 units, total demand would give you 750 units. So you find out that demand is in deficit. Supply, which is 900, exceeds demand by 150, which is here, 150 units. So since demand has been exceeded, then you have to add demand. So add 150 units to demand. Destinations are, they obtain demand, so you would have to add another destination. Also just like this. This one plus this one plus this one was 900. And then you had the destination 300, 200, and 250, which is 750. Then you have to add 150. Just have to add this 150 that is here, so as to make it 900. So if you had 150, then you would have to add another column, which you would call column 4, destination 4, and you assign the zero cost here because it's non-existent. You are just doing it for the sake of computing the optimal solution, but actually it's not existent. So just put there zero costs. All right. After there, you are done. You have already balanced the problem. So it's just like that. Now let's go to another example here. Example 2. We are saying the following data regarding demand and supply relates to XYZ Ltd. All right, we are told to convert the above unbalanced transportation problem into a balanced transportation problem. The problem seems unbalanced and you can prove it. You can just check it. So we just, as usual, check total supply and total demand. Total supply right now is here 300 plus 200 plus 300, which gives you a total of 800 units. And then we have total demand here, 350 plus 200, that is 550 plus 350, that gives you 900. So you find out that our demand exceeds supply by 100 units. Since demand exceeds supply by 100 units, then you would have to add 100 units to supply so as to reach 900 units. So you come down here, you would have this is supply 300, 200, and 300, that is 800. Then you have to add another 100 so as to reach 900. After doing this, actually, it means that you have added a row, another row that you would call number 4. And then, as usual, the cells created would be assigned zero costs. And that's all. That's all. Up to that, we have already done that. So you can just go to step 2 to obtain initial basic feasible solution. Thank you very much up to there. All right, see you later.